Okay, here we go. Now, let fx equal this typical representation of cos and this representation of sine. So we got cos x plus pi and 2 sine x. Now, what does this mean? So first here, this sine x has been stretched upwards and downwards by 2. So this is a stretch in the y-axis. So we have to draw the gx function first, which is probably easy to do first. So here's a regular, let's just draw a regular sine. It looks a bit like this, right? And on this side too. This is the sine wave where you got a maximum height of 1 and the minimum height of -1. So now this graph, 2 sine x means there's going to be a stretch on y-axis. So this is now going to stretch right to the top here and go back down. Stretch right to the bottom here. That's a curving actually. And then go back here. So it stretches all the way to -2 and all the way up to +2. As for the cos x plus pi, and oh yeah, it does the same on the left side. As for the cos x plus pi, that's just a shift in the x-axis. So if it's plus pi, it means shifts to the left. So this is a left shift by direction of pi. Just a reference to the sine graph. The sine graphs here, and these are the following points here. At this point, intersects at pi, and this is 2 pi. These points here are basically pi over 2, so half of pi. And these points here is 3 pi over 2, so 1.5 pi. So halfway between pi and 2 pi. And the same could be said for the negative values. As for the cos x plus pi, let's just draw it out here, yeah? Always good to have it out. So the regular cos x graph will look a bit like this, yeah? So let me just extend the line. So here's the blue line. There you go. So this tells us that at this point, this is pi over 2, this is pi, this is 3 pi. That's quite poorly done. So this is 3 pi over 2, and this one here represents 2 pi. Okay, so this is pi here. So if you're going to shift this to the left now, following this example here, what exactly happens? Well, I'm going to change the color pen. All this means is that this entire graph, so this point is going to hit here, this is going to hit further down. So let's have a go. So if this shifts here, this is going to be here, this is going to be here now. Negative, this will be a negative pi over 2. 3 pi over 2 is going to be here, and this one's going to be here. So it's going to look a bit like this now. So it's just a shift, and it curls back up here, all the way to minus pi. And that's it. So does this mean anything for these questions? No, not really. All it means now for the amplitude, frequency, and period, or at least for cos, is that it doesn't change. How do we know? So what is the amplitude? The amplitude is defined as the following. According to the CGP book, the amplitude is the height of the wave, literally this little gap here. So going back in our diagram, it's just going to be literally this part here, or I don't know, this part here even. And we know that they both have 1. According to the sine wave, because it's 2 sine wave, it's a really long amplitude. So the amplitude for the sine wave, that's right here, equals 2. Whilst for the cos graph, the amplitude here is going to be 1. It's just a standard 1. Now, how about the frequency and the period? Well, the frequency is simply how many complete waves we have per second. So if we start from here, we can see it completes all the way here. So this is known as a complete wave from when you do a full circle. Now, going back to our graphs, we can say that if we start from, let's say, this point here, from 0, if we follow this line right to the top, it does a complete wave of 2 pi. So technically the frequency is 2 pi. And it's also the same for the sine. It also starts from 0, ends at 2 pi. So this is also 2 pi. So frequency here is 2 pi. So nothing really changes. The period is simply the same thing as the frequency, but it's now 1 over the frequency. So the period is 1 over the frequency, which is 1 over 2 pi. And likewise here, this would also be the same one.